Hello, I'm Dr. Sri Banerjee, epidemiologist, biostatistician, and educator. In this video, I'll be going over some explanations of epidemiological measures. So let's get started here. So to start the story of introducing you into epidemiological measures, I'm going to take you to a village in Africa. And then we'll change gears and then talk about some of these measures in general, and as it pertains to specific diseases that I personally have conducted research in, and that is namely prostate cancer. So once I illustrate this, we'll wrap it up with some tips and tools that you can take in your learning. So let's go back to 1981 in Mozambique, and a number of physicians get a message through telex saying that there's a mysterious paralysis being experienced by individuals, and what is unclear at this point is that what exactly is causing it. There is this condition that villagers know this as, where literally there's the feet are tied and the legs are tied, and so there's no loss in sensation. The physicians get to the village and see that they do some exam, a physical exam, and they see that there's really no loss in sensation or in terms of urinary or bladder control, but they do see that motor neurons are affected. And this is not quite like polio because of how the deep tendon reflexes, how they are. And so that's the distinguishing factor, and this has physicians perplexed, and public health officials at that point. They're scurrying to determine what is causing this paralysis. There are all these theories about potentially there being some sort of condition that has been characterized by a indigenous tribe from current-day Democratic Republic of Congo, and so there's some ideas that might be what is causing it, but still there's really no idea as to what it may be. Potentially another infectious disease might be spreading. So they get together and look at what may be different. So what happened there was that cassava is a plant that is grown there, and so I'm going to tell you what is going on when the cassava plant is not properly cured. It's left to it's picked too early. Then there's a lot of cyanide. So literally, the villagers were being poisoned unintentionally, but because the plant was not processed in the right way. So this is an example of an epidemiological investigation, and I like this example because it shows the parallels between infectious disease, but also establishes the notion that epidemiology goes well beyond looking at infectious diseases. While we got this start in understanding, I mean, epidemiology goes back at least 2,500 years, going back to the Greek times, and some would say civilizations even before were practicing epidemiological methodologies and techniques. So the history it goes way back, but during the modern times, these are some of the stories that make up epidemiology. If you go back to the Crimean War, of course, Florence Nightingale was one of the first nurses to typify the death rate in certain regions in the war theater. And this was in the 1850s. So in many places, not only John Snow, but many others in the 1900s, W.E.B. Du Bois was doing a lot of work in neighborhoods in Philadelphia, looking at epidemiological social disparities. So there's a lot of history from many different backgrounds. So now thinking about how this translates into looking at prostate cancer and looking at some practical applications of basic epidemiological measures. Um, so So now transitioning over to talking about prostate cancer, but first let me uh, just continue on from the last conversation about uh, the the Konzo disease. So the name of the disease that is causes paralysis is Konzo, and this comes from actually a term used by the Yaka tribe in the Democratic Republic of Congo, who uses this as a fetish to hunt wild game for food. So this is something that is used to target the leg, and so from that comes the term of Konzo. So these are some interesting kind of facts, epidemiological connections with indigenous tribes, and I think these connections are important to identify as we're describing epidemiology. So now thinking about a nice geospatial perspective and context in typifying a cancer type that really still affects the male population immensely, and that is prostate cancer. So there's still, even though a lot of good screening tools, of course, prostate-specific antigen and other diagnostic tools have been developed, there's still incidence rates. And so it's good to look at, when you're thinking about epidemiology, the five W's. And so, of course, when you're thinking about a story, who, what, when, where, why, sometimes how. But so these are what you want to maybe think about, right? So when is time, right? So temporal trends, and then where is another W. So geospatial, um, and then of course person. So in terms of what are some other ways that you classify. So if you translate all of the W's, you can actually pretty easily construct an epidemiological sort of study in a simplistic way. So when we look at this map, I want you to pay attention to the red. Specifically, when you're creating a map, there's choices in the types of colors that represent certain rates. So the incidence rate is greater than 118 per 100,000. So a couple of things I want you to pay attention to here. This is a rate, it's not a count. When you have a count, there's not a denominator. But when you have whether it's incidence or whether it's prevalence, and I explained the difference in another video, but it's usually a rate, and it's extremely important that you know what the denominator is. And so in terms of how this plays out, in the geographic distribution, a lot of the southern states, Georgia, Alabama, Mississippi, Louisiana, so this is looking at 2012 to 2016 data. Um, there's really a lot of incidence rate, and so even South Carolina and North Carolina. But then when you go into the northern states, we don't see too much going on in Virginia. Definitely not as much in West Virginia, but then as we go up into the northeastern states, Pennsylvania is a bit higher, and then New Jersey is a red state. And I would assume that some of the New Jersey rates are from Pennsylvania, and of course the D.C. area, also, and Maryland, have really really high rates of prostate cancer, and so a lot of the patient population that I saw was from New York, and then in Baltimore. So this is in hospitals and in many settings. This is a major public health issue, and so um, I actually teamed up with a urologist practicing at the time, and we were able to gather worldwide rates of data of prostate cancer from SEER, from GlobalCan, and other data sets. So I'm going to go into that a little bit more. But this is looking at current trends and really showing you specifically answering one of the W's, which is where. So this shows you pretty distinctly. Now, as promised, in this segment of the video, I will be going over um, a original research article that I teamed up with a urologist and worked on. And the name of the article is Worldwide Prostate Cancer Epidemiology: Differences Between Regions, Races, and Awareness Programs. So what we did is we first looked at World Health Organization, how frequent this cancer is, and we found that this was the second most common cause of worldwide cancers. Um, so this was really important. About back in 2012, 1.1 million people had this, and this has only gone up since then. So what we did is we looked through a lot of the current literature, and then went into some of the looking at age standardized, not only incidence rates, but also mortality rates. And so per 100,000, if you again look at the denominator, I told you, pay attention to that, and take a look at the differences between low and middle income countries, some of them, and less developed regions, and then high income countries, and look at the differences in not only the case rates, but also the death rates. And as you can see, the death rates in some of the African countries are actually higher than what you see in high income countries. So that is an interesting pattern that we immediately noticed and wrote about when we were looking at these. So as you can see, it doesn't take too much of statistical processing. A lot of times you can locate patterns by looking at graphs and figures. And so, again, this is showing age standardized. Let me get into the age standardized a little bit more here. So the question may arise is that the reason that the differences exist between different countries is that the aging population maybe higher in high income countries, more so than in low and middle income countries. So the differences that you see may just be due to age. So in order to adjust for that, age standardization is critical. So then we can for sure say that the reason that these differences exist are not due to age, because age has been standardized. So the rates have been calculated by age, and then from that there has been a standardization conducted. So then the final part goes into the numeric portion of the comparison and incidence rates and mortality rates between high-income countries and low-income countries. And at the time, we used the designation developed versus developing, but a little bit more aware, culturally aware and sensitive term is high-income countries versus low and middle-income countries. And we do talk about the widespread introduction of prostate-specific antigen as being a screening tool, but also needing aggressive screening and more knowledge about genetic and lifestyle associations and why there's a higher preponderance in specific populations. And so a lot of this work is looking at incidence rates, prevalence rates, and mortality rates. So as you can see, there's a lot of these basic epidemiological measures. If you really put them all together, you can optionally make colorful maps, and as you saw within the example that I showed you in prostate cancer incidence rates, or you can present this in figures or a combination of both. So I hope this has helped you not only understand the importance of incidence and prevalence rate, but in the context of diseases such as cancer, how this can be a useful gauge to better understand patterns and epidemiological measures. Thank you for listening.